Clean architecture is a modern approach to software design that helps create maintainable, testable, and scalable systems. It was introduced by Robert C. Martin, also known as Uncle Bob. The key principles focus on separating concerns so that each part of the system has a distinct responsibility. This separation allows us to build robust software that can evolve with fewer risks of bugs or complicated changes. In this video, we will cover essential interview questions based on Uncle Bob's principles, including dependency inversion, use cases, and entities. Entities are the core business objects in clean architecture. These objects represent the fundamental concepts and rules of the business domain. Entities encapsulate business logic and remain independent of external factors like databases or user interfaces. For example, a user entity will contain methods to perform key business functions, such as checking if a user can register. Keeping entities pure and free of external dependencies makes the core business rules stable and reusable. Use cases represent the specific business actions that an application performs, implementing business rules in the context of the application's requirements. They orchestrate the interactions between entities and external systems. For example, a register user use case uses the user entity to verify if registration is allowed and then proceeds to save the user in the system. By focusing business logic into use cases, the application remains flexible and easier to maintain. The Dependency Inversion Principle is a key concept in clean architecture that promotes decoupling high-level business policies from low-level implementation details. Both high-level and low-level modules depend on abstractions or interfaces, not on concrete implementations. This allows the system to be more modular and adaptable. For example, a user notifier class depends on an email service interface, so that the actual email sending mechanism can be changed without affecting the notifier logic. Also called hexagonal architecture, the ports and adapters pattern separates the core business logic from external systems through well-defined interfaces called ports. Adapters implement these ports to connect the application to the outside world, such as databases, user interfaces, or web services. This separation allows external components to be replaced or updated without impacting the internal business rules, making the system more flexible and easier to evolve. Clean architecture is used widely in the software industry to build robust systems. Android applications often apply this pattern to separate user interface code from business logic and data access layers. In iOS, the Viper architecture follows similar separation by dividing the app into view, interactor, presenter, entity, and router layers. Web applications built with frameworks like ASP.NET Core use clean architecture to improve testability and scalability. Large companies like Netflix use these principles to design microservices that operate independently with clear boundaries. Using clean architecture brings many benefits to software development projects. It improves maintainability by clearly separating different parts of the system, making future changes safer and easier. Testability is enhanced as business rules are isolated, allowing developers to write focused automated tests. The architecture's flexibility enables swapping or upgrading external frameworks without affecting core logic. Loose coupling reduces dependencies between components, simplifying collaboration and development. Overall, clean architecture helps teams build clearer and more understandable code bases. Although clean architecture provides many advantages, it also comes with challenges. Initially, it requires more design effort and can seem complex, especially for small projects. Developers need to learn key concepts like abstraction and dependency inversion, which may steepen the learning curve. Sometimes, teams may overengineer by adding layers unnecessarily, which can slow down implementation. Additionally, the extra layers might add slight performance overhead. Finally, successful adoption requires cultural changes and discipline within development teams to consistently follow architecture principles. To effectively implement clean architecture, start with small projects to build understanding before tackling larger systems. Focus on defining clear interfaces to separate responsibilities and create boundaries. Keep domain entities pure by including only business logic free of external dependencies. Employ test-driven development to guide design and ensure code quality. Lastly, adopt clean architecture incrementally, improving existing systems gradually rather than rewriting everything at once. These best practices lead to easier maintenance and better software quality over time. Clean architecture is applied in many real-world software systems. In Android development, it organizes apps into layers for user interface, data handling, and business logic. Viper in iOS is a derivative pattern focusing on modularity and testability. Web frameworks such as ASP.NET Core implement clean architecture to separate concerns and allow independent testing of components. Microservices architectures used by companies like Netflix benefit from the clear boundaries and loose coupling promoted by clean architecture, facilitating scalable and maintainable distributed systems.
If you like this video, hit that like button and don't forget to subscribe. Visit CodeLucky.com for more such useful content.